In step one of the lab, we need to find the focal length for the lens. So I'm going to show you how you would do that experimentally, and then instead of measuring, I'm just going to tell you what the focal length is because I've already measured it. So the way we find the focal length for a lens that you don't know, you just find, a magnifying glass in your grandmother's kitchen. Okay, well, what's the focal length of the lens? Well, it's really easy. You just take the light from a distant source, and the reason why we want the light to come from a distant source is because all the light rays, once you get far enough away, are basically parallel. So you think about like the light from the sun goes out in all directions at all angles. But when you're here on Earth, the light from the sun, it has to be pretty much parallel, straight from the sun in order to reach the Earth, because if the light ray was a little bit above the Earth, well, then it would just pass a little bit below. So they're basically all parallel. So this is true for all light rays. So I'm going to take the light from that window over there, I'm going to pass it through this lens, and I'm going to have it project an image up on the board. So here, as I get close to the board, you can see that when it's focused here, we have a nice image of the window. Notice that it's upside down. We have the sky here and trees down here. And if I was to measure this distance from the lens to the board, that would be my focal length. Since there's just one of me here, I've already measured it, and the focal length of this lens is 250 millimeters. The focal length, again, of this lens is 250 millimeters.